Hi, Pre-Calc. We're going to talk polar coordinates here. We just transitioned from trigonometry, and what you're going to find here is there's a huge overlap between what we're going to learn now and what we just did. So we know that when we talk about direction, we talk about Rochester is about 60 miles east of Buffalo. So we don't talk in terms of positive and negative. We talk in terms of direction and distance. So when you're graphing a typical point, it's just x, y. You have positives and negatives. That's just in the Cartesian plane, like the xy plane. Now we're going to move into something called polar coordinates, and these deal with r and theta, a radius measure and angle measure. So we have a distance from the origin that's going to be called the pole, and the angle measured from that fixed direction called the polar axis. And we know from last unit that's like the positive x-axis. There's your rotation. So this is called the polar axis. And the origin we're just referring to as the pole. And we know we created right triangles here. This radius measure, that's going to be what this r refers to. Okay, so r is just the distance from the pole to the point, and theta is just the angle created from the polar axis to this other line segment. And we know that x, our x value corresponds with cosine, and our y value corresponds with sine. So we're going to kind of dig into that here a little bit, but more so on the next page. So if we think about imaginary numbers for a minute, we know that I is the square root of -1. You can graph complex numbers in the complex plane. What's different? You have the x-axis, and instead of the y-axis, you have the y-I axis. So this is the complex part, or the imaginary part. So when you graph a complex number, it's written as a vector. So it has a magnitude, it has a direction, and a distance. So here, if we graph the complex number 2 plus 3i, we go to 2 on the real axis, 3i, we go up 3 on the imaginary axis. And then we're going to draw a vector starting at the origin, ending at that point 2 plus 3i. We call that rectangular form. Complex numbers are written as x plus y, that's rectangular form. So the reason we're using a vector is it describes the direction and the length, the direction and the distance, which is what we do with polar coordinates. So if we have this right triangle here in quadrant 1, and we have this angle that we're measuring, theta, we know that the formula for sine is y divided by r, cosine is x divided by r, tangent is y divided by x. And we know that x squared plus y squared equals r squared. If we want to solve for r, we can take the square root. So r is the square root of x squared plus y squared. We talked about r always being positive, so that's why I'm not including the plus or minus. If I wanted to solve this equation for y, if I multiplied both sides by r times r times r, y is going to be r sine theta. Similarly, cosine, if I do that, will be r cosine theta. So if we take that and substitute that into complex form, x is r cosine theta, and y is r sine theta times I. And they both have an r in common, so if we factor that out, it's going to be r times cosine theta plus I sine theta. This form is going to be referred to as trigonometric or polar form. And it describes the location of a point on the complex plane using the angle, theta, which is the direction, and the radius, the length. So just summarizing here on the top of page 3, trigonometric or polar form is r times cosine theta plus I sine theta. Sometimes it's just abbreviated as r cis theta. C standing for cosine, I for the imaginary unit, and S for sine. R is the length, theta is the angle. In the next video, I'm going to go through how to convert from trigonometric, this polar form, to rectangular form.